So welcome to Irodov problem solving series, and we are solving problem number 2.12, and the problem is stating find the minimum attainable pressure of ideal gas in the process T equals T naught plus alpha V square, where T naught and alpha are positive constants and V is the volume of 1 mole of the gas. We also need to draw the approximate P versus V plot of this process. So let us begin with the equation that is given to us. The given equation is T equals T naught plus alpha V square. Now since over here in this term there is no expression for pressure, and I always state this whenever you are solving a problem and it is mentioning ideal gas, we always have this additional equation PV equals nRT. So over here n equals 1 mole as mentioned in the problem, that we have n equals 1 mole. So we can definitely rewrite this expression as PV equals RT, and from here we can write pressure as RT by V. Now if we substitute the value of temperature from this expression which we have, then we can say that the pressure equation becomes P equals R by V, and temperature terms becomes T naught plus alpha V square. So this is the expression for pressure which we have. Now we need to find out for pressure to be minimum. So we are writing for pressure to be minimum, then we are writing dP by dV equated to 0. So therefore if we are writing dP by dV equated to 0, so we have derivative of, so now we have denominator term also contains V, so we are using the division rule. So if we use the division rule, so what we will do, we keep R constant or R outside the derivative box, denominator is square, then we fix the denominator and we differentiate the numerator. So on differentiating the numerator, derivative of T naught is 0, alpha V square will give us 2 alpha V, so we get 2 alpha V. Then we differentiate the denominator fixing the numerator with a negative sign. So with a negative sign, if we fix the numerator, R is already kept constant outside this box, and then if we differentiate this term, dV by dV is 1, so we get an equation like this, and we equate this to 0. So on equating this to 0, we get the expression R by V square, then we have 2 alpha V square minus T naught minus alpha V square, and this is equated to 0. That is, we can put V square by R separately. 2 alpha V square minus alpha V square is alpha V square minus T naught equal to 0. So from here we obtain V equals root over T naught by alpha. तो ये हो गया हमारे पास पहला expression which we have, and this is the expression for dP by dV which we have obtained. So dP by dV which we have obtained is equal to R by V square alpha V square minus T naught. Now we are going to calculate the second derivative. So to check if this is the minimum value, we need to check for the second derivative. Therefore if we are calculating second derivative, d square P by dV square. So if we are calculating the second derivative, denominator is squared, V to the power 4, numerator we will be differentiating the numerator keeping denominator constant. So if we differentiate this, we get 2 alpha V, T naught derivative is 0, then we put minus sign, again R is kept constant outside the box, then we take alpha V square minus T naught constant and we differentiate V square, so we get 2V. So this is the second derivative which we have. So R upon V to the power 4, V square term, V cube term taken common, then what we have 2 alpha minus 2 alpha minus 2 T naught. So 2 alpha and 2 alpha cancels out, plus T naught. So 2 alpha and 2 alpha cancels out, and we get this expression as R by V times 2 T naught. So this entire term is positive. So we have this entire term as positive. So hence we can say that the condition which we have obtained is the condition for minimum, and if we substitute this expression then we will get the minimum pressure value. So for pressure to be minimum, we say for pressure to be minimum we need to put V equals root over alpha by root over T naught by alpha. So minimum pressure turns out to be 2R root over alpha T naught. So this is the answer for this particular problem. Now in the question it is also asked to plot the graph of P versus V. So if we plot the equation of P versus V, so P versus V is going to look like this. So we have a y axis, we will be plotting P, and on x axis we are plotting V. So PV curve is going to take this form. So for PV curve we have a curve like this, and this is the point where pressure is minimum when volume V is equal to root over T naught by alpha. So this is the value of minimum pressure which we calculated as 2R root over alpha T naught. So this was problem number 2.12.